Here we'll see about combination. Combination is the arrangement of objects without giving concern to the order of the matter. So AB is the same as BA and ABC is the same as ACB or BCA or CAB or any other combination. But now, say for example, we take two of those three letters. Here in the example, we have a set containing A, B, and C. So in how many ways can we choose two letters from these three? So we can choose A, B, and B. We can choose B and C. We can choose C and A. Other than that, it's going to be duplicates. The rest are going to be duplicates, meaning if we choose BA, then it's the duplicate of AB. So if you notice, we have three ways out of three objects, which is 3 equals 3 factorial over 2 factorial times 3 minus 2 factorial. But 2 factorial is the number of objects we're taking. So here, to generalize, the combination of n objects taking r objects at a time, here in this case we took 2 out of 3, it is defined as, it is actually n factorial, the number of objects factorial, over the objects we take factorial times the difference between the two factorial. It could also be written like this, if you notice the arrangement: C bracket n r اللي هون يشلال ويم دمو n C sub r اللي هون يشلال. Okay, next we have some properties, not very useful, but you can pause the video and read these. They're not worth explaining. Okay, so if that's the case, let's go to the next one. Probability, finally, right? We have three definitions for it. The classical one, which is the one we'll be focusing on, will be it assumes that all outcomes are equally likely, and it's mathematically defined as probability of an event, P of E, is equal to the number of objects, the number of outcomes in the event, over the number of outcomes in the sample space. For example, for a die rolled, getting a 1 is, the probability of getting a 1 is 1 over 6, because 1 is the number of outcomes in the event, and 6 is the total outcomes we can get. Next, we have empirical. Not very, we won't go deep into this. Empirical just means let's try everything before we can find out. So let's toss the coin a million times and see the ratio of occurrence and non-occurrence of heads. Okay, let's go to formal. Formal just states these. Formal says that the probability is always between 0 and 1. If it's 0, that means it will never happen. If it's 1, then it's absolute, it will happen. And it also says that if an event is the union of other sets events, then the probability of that big event is equal to the sum of the probability of the smaller events that make it up. So this can be extended to any finite number of events. Now let's go to something more interesting, which is conditional probability. This is usually feared by most students, but I have found an easy way to understand it. Conditional probability just means shrink your sample space to whatever you're given. It's like saying, if for example for a die, if you find 2, then you win. So if I say, what's the probability of getting a 2, if I already told you that you can get 2, 3, and 4, then that would be 1/3. So let's see it. You shrink the sample space to what you're given. So here it says probability of A slash B, meaning A given B, is equal to AB. AB, by the way, means here. AB is the same as A intersection B. That's what it means. We just read it as AB. So probability of finding AB, the intersection, over the probability of B. That's what we want. Or you can write it as this. This is my version. This is the simplified version. Just cancel out P and then just put in N. How many elements are in A and A intersection B, and how many elements are in B, and then you can find that out. If you flip B and A, if you're given B and then you're asked to find A, if you're given A and you're asked to find B, then you can still find N of AB over, it will be N of A. The bottom one will be changed. Okay, so let's just take an example. A is this, B is that, and C, and the sample space is there. So A given B, according to my definition, is number of objects in A, B over number of objects in B. So we have two objects in AB because their intersection is only 2 and 3, and then we have three objects in B, that's B, so our probability would be 2 over B. If you use the normal definition, that's the same answer you'd get, but I see that this side is simpler, so I recommend you use that. That's it for probability.